So whenever we start a new project, maybe following a tutorial, creating a simple hobby project on a weekend, we tend to do a couple of things that are quite repetitive. For example, you want to initialize Git in the project root directory, you want a readme.md file living in it so others know what the project is about. And on that note, you also want to have a git.ignore or a local Visual Studio Code config, so like something like .vs Code config or whatnot, depending on a code editor or your preferred development tooling. So if you're a Python developer, and you most likely are since you're watching this video, you also want a virtual environment where you install all the dependencies in isolation for this new project. If you're a JavaScript or front-end developer, you'll want Webpack, Babel, package.json, and the sorts. Basically the equivalent of requirements.txt and some project initialization files. And what most developers do is to create these files individually, so sequentially, sometimes out of pure habit or muscle memory, right? And wouldn't it be nice if we just write a simple project starter that essentially does all of this in one simple shell command, something like cookie cutter but written from scratch to make it specific for our use case, and also for learning purposes. And the best part of it all is that we built this tool using just Python and its standard library, so no external dependencies, kind of the theme of this series. Now the program will come out to be around 20 to 30 lines of code, pretty lightweight, and will save us lots of repetition, especially if you tend to just be doing the same kind of routine work whenever starting on a new project like I do. And the user experience would be very simple. We would just call starter, basically just to show you how it looks like, we just call like starter. Right now it doesn't exist yet, so it's a red, but when it exists you have a blue, and then followed by the project name. So if I want to create a project for home automation, so I'm moving to a new place now, I want to build a Python toolkit to work with the automation things around my house. So I want to have like home automation, and if I were to just hit enter, so automation, if I were to just hit enter, it's gonna go ahead and create a file, put git in it, gitignore, and then create a virtual environment, put requirements.txt in it, and then we'll go ahead and just create proceed to maybe create our first commit, and it will go ahead also to create a task. So I have a task bot, my task manager. You can see all my tasks here, but it's also gonna go ahead and create a task saying that, oh, make sure you write the documentation for this one and add that into my task manager. So basically automate my whole workflow, and that will just do all of that work for me instead of me having to write, doing the same thing again, right? Create a new folder, virtual environment, install requirements.txt, gitignore, all of that stuff, readme, all of that stuff. All right. So just for good measure, I'm gonna use Task Warrior for that. So there is a project that this is in another video. You could go and find a link to that video in my description, in this video description, and it would be building a task manager app. So you could have something like that. You could look at, for example, okay, it doesn't have that yet, so I need to work on, I think, Live OS, and then I could say TQW. I could see like how productive am I, and this is basically a scoreboard for myself, so I could see how much time I spent on working on tasks and whether I'm doing enough or whether I'm being productive. So I basically have the system. I want to have this project sort of wired up to my task manager system. But anyway, if you don't know what Task Warrior is, you want to check it out, go and the link will be in the description. Just go and check it out. It's a really cool to-do manager. In my other videos, we built a few really cool utilities using only Python standard library, just like this video, without any external dependencies. All right, so just exactly like what we're doing today. So if you're relatively new to building tools for the command line, or you just started learning OOP or unit tests in Python, you'll love that series, I promise. Okay, enough chatter, let's write our first line of code. So I'm gonna go ahead now, and let me just quit that out so you can see everything in here. So I'm gonna just quickly open up Python, get Python running. I'm still not gonna touch the Visual Studio Code yet. I'm just gonna be working in Python, and I'm gonna show you a few main ideas first before we start to write that program out. All right. So the first idea I want to introduce to you is the subprocess module. Now this is there is a really great article on Real Python. So that is where I adapted this example from. And I encourage you to go and give that a read by searching for Real Python subprocess. So we're going to be talking about subprocess, but I'll help paint a general idea of what it is and how to use it. So whenever you do something on a computer, you're interacting with one or more programs, and a process is the operating system's extraction of a running program. So when you launch an application to maybe write some simple grocery notes, or when you use a web browser to find a dinner place to bring your date, your wife, your siblings, whatever, right? That node application or that web browser basically starts this running process. In fact, you can visualize this by using the built-in top. If you're using, I think, Linux, Unix, Mac, I think Windows as well. There is I'm not sure. I don't think Windows works, but there is top, and on Linux, a lot of my friends, a lot of folks would just go ahead and install htop, which is a bit more visual, a little bit not nicer, and this is kind of it's a list of all the processes, and you see like one of the main things you see is PID. So PID basically is the process ID. So this is it, right? PID. And you see that everything that you do on a computer, when you start a program, you're starting a program, it actually launched this, it creates this process. So that's the abstraction of a running program, right? And you will be able to see PID, and it will tell you who is the user who started that program. It will tell you how much memory is taking, how much CPU is taking. So for example, you could customize this, and you could change that. If I hit Shift P, it would just go to it would just sort it about your CPU, and it will tell you that, okay, right now Obsidian is using a lot of CPU, and it's also using quite a lot of memory, but CPU is using 56% of CPU. And why is that? Because Obsidian is a pretty heavy software. It's a pretty heavy program, relatively speaking, all right, to the rest of the things that I have on my on my computer right now. And if I want to sort that by memory, I go and hit Control M, Shift M, and then it will just sort by memory, and so on and so forth. So there's a few couple things you can try and sort of tinker with, and then you can build it. You can also look at the tree view, and it's pretty cool, right? There's a lot of information in here, but really the main thing is that if you're sorting by PID, for example, you see that there is a PID, and you could look at the first one is always going to be the root. That's the main thing, that's the parent, and it spawns all these other processes. All right, so this is the subprocess, and what we're going to be using today is the subprocess module. So I want to talk about the subprocess module, and I want to show how you could use the subprocess module as a developer to launch processes, and when it does that, how does it create a subprocess, and so forth. All right, I'm going to quit that out first, and let's go back into Python. So to use subprocess, let's go ahead and just do an import subprocess. All right, very simple stuff. This is built into Python. You don't have to do any kind of fancy pip install, nothing, just standard library. And when you use subprocess to launch a subprocess, basically that's the name, right? It comes from that. When you use this module to launch processes, it creates a subprocess or a child process. This can be a GUI application, a GUI application. It could be a shell command. It could just be any about any text program. It could be any of that programs. Okay. In fact, you can try it right now. Maybe just spin up Python and then process to call your node editor, for example. So let me just go ahead and say subprocess.run. And depending on what OS you're using, you want to try something that you have. So for example, if you're using Windows, you want to try Notepad. So you want to do Notepad like that. And then you want to close that, and you just hit enter. I'm not gonna run this because I'm not on a Windows, I'm on a Linux. It doesn't have Notepad on it, so it's gonna throw saying that you can't find that file. All right. But if you're on a Mac, you want to try something else. On Mac, you probably use TextEdit, but you'll use the Open instead. But anyway, for Linux, mine is the gedit. So I'm gonna go ahead and say gedit, and it will run, and I hit enter. So what's gonna happen is that a gedit process is gonna be spawned, and gedit is gonna just boot up, right? I'm gonna close that out right now, and I'm gonna try that again. So let's just run that again, and again you see it pops up. So and every time you close it, you see that there is a completed process, and it gave you an argument, and it says return code 0. Return code 0 is what we want. So 0 means that it exits without any error. Anything that is not 0, there's an error. Okay. So depending on your Linux distribution, you may have a different text editor. In that case, you don't want to put gedit, you want to put something else. You want to maybe use Kate, Leafpad, Anki, etc. If you don't have any text editor because maybe you're a hardcore Veeam user, actually Veeam also works, right? You could go ahead and just try like something like Veeam, and we just go ahead and launch my Veeam, right? You can hit Q to sort of quit that out. Don't worry about Veeam or Emac if you don't know what I'm saying, but here you can launch a text program, you can launch a GUI, you could even try Firefox, for example. I'm gonna just go ahead and say Firefox, right? And let's just go ahead and run that. If you have Firefox running on your computer, let me just run that. It's gonna go ahead, and what's gonna do is it's gonna spin that out. So I'm gonna close that out right now, run that again. You see it boots right up, and I'm gonna close that back out again. All right, and just clear the screen a little bit. So by this point, you'll be like, wow, I could automate a ton of things using subprocess, right? There's so much things you can do with it. As long as you can call it in a shell and a command line, whether it's a GUI program, whether it's a text program, whatever it is, right? You could just use subprocess to start and stop programs or processes at will. And it's truly tempting at this point to want to just reach for subprocess every time that you need to automate something, anytime you want to write some script, a command line utility. It's kind of like, it's the kind of thing that once you learn it, you'll be like, oh, from now on, from this point on, every time I need to write some sort of automation or some sort of doing some sort of CLI program application, I'll probably reach out for subprocess again. And you probably want to just hold your horses right there, because for a variety of automation tasks, there is a good chance you'll find a higher level utility that is specific to that task, something that I explore in my other videos that feature web automation using Selenium, using web browser module. Speaking of web browser, say you want to write a Python script that opens a browser and performs some sort of data collection or data scraping, whatever, something I've shown in my other videos. I'm going to point you to that video. I'm not going to talk about that here. So instead of using subprocess, a more productive, a more robust workflow is to use the Python module web browser. So that is kind of like, this is it, right? I'm going to say import and web browser. And you could just say webbrowser.open and you put a link and it would just open that up. Now the web browser module uses subprocess under the hood, but it handles all these tiny, messy, different cross-platform and cross-browser compatibility issues. So it gave you a more consistent API, it gives you a more consistent developer experience. All right. So you probably don't want to reach for subprocess for, I mean, you don't want that to be your first impulse. It's like, hey, I want to write something, I want to open, work with some PDF files and then get my computer to do something, and I want to get my browser to do something, let me use subprocess. There is a good chance there's a higher level utility that is built that under the hood uses subprocess. Right, is what I'm saying. Let's maybe talk about one or two more issues, one or two more sort of main ideas, and then we can go into our code and actually write the program out. All right, so let me clear my screen now, and I want to say what happened if we pass in a program that it couldn't find on the computer. For example, I'm going to go say subprocess and run. Now, instead of running something like gedit, so we did gedit earlier, instead of doing that, this is obviously going to run. It's going to find a gedit file, it's going to boot that up, but it's going to start a process for that. But what if you put in something that it doesn't exist? For example, 333, right? Doesn't exist, gedit 333. So let's run that. Well, what does it say? It says there is no such file or directory, gedit 333 file not found error. Okay, this is good. This is actually important because later on when we write our program, we want to cater for the fact that what if the user who is using our script, they don't have git installed, or they couldn't find, for example, the specific text editor, for example. What happened in that case? What happened if the user doesn't have the task manager that we use, right? So what happened in those cases? So we need to know how to handle those kind of exception. That's why I spent some time talking about this. And let's also try a couple of things. So when I try a program that doesn't exist, so something that doesn't exist, this something that doesn't exist, right? It's gonna just go ahead and just say a file not found error. That's good to know because later on when we write our script, we could do a we could catch the exception and we could handle the exception, all right, and give a friendly message saying that, hey, there is no such file or directory, all right? Okay, but what if there is actually such a file or directory, but you did not pass in the right thing? For example, let's say git add or task add, right? So let's go ahead and just create a process. We're gonna say subprocess, and we're gonna say .run, and in .run again we pass in an array, right? So let's say I want to say something like, let me show you this. I'm going to clear my screen now. And in order to add a task on my task manager, so this is my task board. In order to write a task, to add a task, I'm going to say something like test, add, and then record a tutorial project. Okay, for Supertype, right? That's sort of that's my consultancy company. We record a project tutorial for Supertype, and if I add this and I run tasks, you'll see that it comes out here. Record a tutorial project for Supertype.ai. All right. So what happened with the syntax? Now I have to pass in task, and then I pass in add, and then I pass in a certain the task itself that I want to be writing. So in this case here, what happened if I go to subprocess.run and I say something like task, right? Okay, no problem. And then I say add. Okay, again no problem. But then I did not pass in anything else. Right, so instead of passing a third item with task add and then record a tutorial project for supertype.ai, instead I just have two items in that array or in that list. What's gonna happen? So let me run that. It says additional text must be provided. Now this is the same as if I were to run this like that, task add. So any kind of error that you see, it's also gonna appear in here, right? But this is actually not an exception because it seems like it didn't throw an error. It just returned this message, but it doesn't actually throw an error. And what's interesting is if you look at the subprocess, you say return code. You see that it returns 2. It's not a 0 anymore. When in the past, if we were to scroll all the way back up, you will see a return code of equals to 0, right? So there's a return code equals to 0. But in this case here, there is no return code. And if you print out the return code, it says 2. So it's actually returning a non-zero exit code. okay, or return code or exit code, the same thing, right? But what's interesting here is that it doesn't raise an exception. It doesn't have the exception that we expect when we do something like this. Here it gives an exception. It says traceback file not found error, no such file directory, gedit 333. But in this case, it didn't seem to return any kind of exception. It doesn't raise any exception. It just basically return silently. So what we want to have is that instead of asking the filling process to fill silently, we want it to fill early and we want to fill loudly. So one way to achieve that is to run this function again, except you want to put a comma and then you want to pass in check equals to true. So like this. And if you do that, now this is the same code except I'm just adding check equals to true, and we run that. Now it gives you a traceback, it gives you a called process error. It says what? It says called process error command task at return non-zero exit status 2. It says that, oh, it didn't give me a non-zero exit, so it must have been an error, and so it gave me a called process error. And that's kind of what we want. Okay, so that's kind of the basic usage pattern. There is a lot of nuances as to how subprocess does the work, interfacing with the different program and the different processes on your system. But I'm gonna leave those out for maybe a different video, maybe in a future topic, or you can just go and read the article. All right. But this is enough knowledge for us to get started. So let's close out this one. I'm gonna also turn off my face to give you more sort of screen view estate. So let me hide my view, and I'm going to bring up my Visual Studio Code now, and let's go ahead now and just start this project. Okay, so you could create anywhere. I'm in my desktop right now, and I created a folder called starter proj, so starter project, because I'm just gonna call it starter. And I'm not gonna actually so right now there's only one file in there, that's demo.0.py. That's kind of me trying to work with all of this in order to show you a demo later, but right now you don't need that file. I'm just gonna assume that it's an empty directory right there. There's nothing, and you can either just go ahead and touch a new file, or you could just create a new file. So let's go ahead and just click on the new file and then give it a name. I'm just gonna call it starter.py. You could also do it from here, just say starter.py, save it, and then now you have a new file called starter.py. There's nothing in there. Let me zoom in a couple of levels so you can see better. Kind of like that maybe. Okay, so what did we say? We say that we want the user to be starting a project by doing starter and then their own project, right? So this is, let's say, my school assignment 1. If I just pass this in and I just hit enter, it's supposed to go ahead and create a new directory and do all of this stuff for me. And because this is working with the a command line, you know that if you watch my other videos, you know by now that we would just go ahead and just do a from out parse import argument parser. All right, and some of you may be tempted to do something like from sys import argument v and stuff. Like, don't do that, because that's such an outdated, we don't code like that anymore. All right, we're living in 2022. We should be coding using modern tools. So use argparse instead, use the argument parser instead. It's more robust, it's more user friendly. There's so much more advantages to be doing that instead of doing the argv approach. Okay, so let's go ahead, say from argparse import argument parser. If this is very new to you, you've never seen this before, I'll point you to another video. If you have time, go and walk through that, the building a whole command line interface with colors, with all that stuff, and then publishing it as a Python sort of Python package. And if you want to follow along that video, I'll give you the link in the description. But from now, let's just move along. I'm also gonna be able, I also need the path utility, so I'm gonna say from pathlib. So that's the path library, import path. So that would allow me to detect the path and create the right files in the right area, in the right places. So in this case here, if I call starter school assignment, it's gonna create that in the current directory, for example, and then create a new folder called school assignment. So I need to detect the path. I know some of you would be tempted to do something like import OS, and then you say something like print something like OS get current working directory. So you would, you could also try and do something like that, and then you can string your you could string your path, and you can say this is path equals to something, path equals to this, and then you would go ahead and then string it. But I also recommend not to do that. There is better tools, there's better ways to do that. And so in this case here, use the pathlib, import path. All of these are standard Python libraries anyway. So just go ahead and do that. And then of course we've been learning about subprocess, so we want the subprocess. So let's go ahead and just do subprocess. All right, I'm gonna bring this up a little bit so you can see, and I can open this up as a Python tree, so we could maybe see it at the same time. And then you could just go ahead and just give it a name, a main function. You don't have to pass in anything right now, but just sort of initialize it. You can say if name meaning if you were to call this directly, not importing it into something else, but call this script directly. So if name equals to main, what do you want to do? You want to just call main. Okay, so you could do something like this. And then here you could maybe give a better name later. You could, so this is a project starter, so you could call it project starter. So project, instead what we're gonna do is we're gonna say Control D, oh oops, no. So I said this, and Control D, I'm gonna say project starter. All right, like this. So if name equals to main, just launch the project starter function. So this is where we're gonna be running most of the code. I'm gonna go ahead really quickly and let's see. Take maybe one argument. So here I'm gonna just give it a project name because I know that the project name should come from the user. So if I were to run G shell, right? If I were to run my starter project and I were to pass in, let's say my home automation project again. So home automation, then this will be the project name, right? I want to run this will be the project name. So here I want to pass in a project name, but where did the project name come from? So so that would be from the outpost itself. So I can first of all go create a argument parser. So I'm gonna say argument parser, and then I'm gonna say take the parser, and I want to add one argument. So far I only need one argument. So the first argument would only just be a simple project name. So you could do something like project name, and you want to say, you can give it a short flag as well. For this, because you're only taking one argument, it's probably not necessary, but you can pass in the type to be string. So home automation should just be interpreted as a string, right? And then from there, you could say something like args, and you can say parser, and you can say parse args, like this. And then in here, instead of putting project name, you actually want to have the args dot project name. So this is a very common sort of building CLI tools. If you done any kind of work using argument parser, this is a very similar kind of flow. So here it says that when we first call the script, right, it's gonna go ahead and ask for the first name, and the first thing being project name, and that is just gonna be passed into project starter. So you could just do a print right now and just print project name if you want to, and you could just print it like that, and you save all of this. Just to test that everything works, we could go ahead and just say Python 3, and we could say our starter.py. And okay, we did not pass in anything, so it prints none. That's correct. But if we were to pass in something, let's say home automation. Okay, we didn't pass in the -p flag, so let's do that. Then it now returns this. So you see that the reason we use argument parser is that it's really cool, right? It gave you a lot of it says the usage pattern. You need to pass in a project name. You can either use the -- project name, the long name, or you can use the short name -p, but you need to pass in something, and the something is home automation, so it just print that out back in here. So this is a very simple scaffolding. There's really nothing fancy in here. All right. We can now go back to this project, and what do we want here? Now, we obviously don't want to just print project name. That's uninteresting. So let's just hit Control Shift K to cancel that out. What we want is to figure out what the path is, right? So we want to figure out what the current path is. You could use the import OS. So you could do something like this. You could do something like import OS, and then you can say os.get current working directory, and it will just print out what the current working directory is. And then you can, some people like to just append to that and then just add a slash and then add that. What turns out, path is more elegant, I guess. So we will use path. If you want to use the OS, you can also use that. Both of them are standard Python libraries, so it probably doesn't matter in terms of adding third-party dependencies and stuff. But let's go ahead, and I'm just gonna call project directory, I guess. Project directory, and I'm gonna say path. And what do I have here? I want to have the current working directory, so CWD. So in OS, you have os.get CWD, that's os get current working directory. With path, you say path.cwd. And then what you do is you just have to pass it as an absolute, and then you can do your append and prepend and stuff like this. So you could go ahead and just put in project name. Okay, you can have as many as you want. So I could do something like this. I could do something like projects, right? And I could do something like project name. Let me show you what I mean. I'm gonna take away that one, but just to show you what it means by what I mean by that. And then I could go ahead and just print project directory. Okay, if I were to save all of that and I get back into my shell here and I run it, now it's gonna go ahead and say, okay, this is where you are at, and I'm gonna go ahead and just put a slash, put projects, and then put a slash, put your project name. And that's really cool because it figures all of that for you. And once you have that, you could go ahead and use this and say something like, let's go ahead and maybe say project dir, which is directory dot make directory. So this is something that comes with the path, right? We don't need a print statement anymore, so we could remove that. And I don't actually want it to be in a separate project, because the way I'm gonna use it, I just want it to be in project name, because I'm gonna make this available on a system level. So anywhere it would just find the current working directory and then just put a slash, put a project name, and then basically create a subdirectory in it, and then from there just call the make directory. So I don't actually need them in a separate in the projects. So I'm gonna just save that. Hopefully all of this makes sense to you. I'm doing it like really step by step, really slowly, so that you understand what each line of code is doing. All right. And then now what do we want to do? Let's actually add some doc string while in here, shall we? Just go ahead, add a doc string. Accidentally created that. Okay, so create a simple subdirectory. Create a simple directory with project name, and then initialize with, then I'm gonna just say the first thing is it's gonna go ahead and create a readme, because almost all the time in all my projects I always want a readme. I know that a lot of my projects, let's just make it very specific. I need a requirements.txt. I know that some of us don't code only in Python. We may have other things. We have like package.json and stuff. I'm gonna leave that as a homework to you, but just to illustrate the workflow here, I'm just gonna assume that's the use case here. But maybe in the future, what you could do is you could have something like this, and you can have dash language being Python. If the language is Python, you could have that. If the language is Node.js project, you could have Node, or maybe React project, so you could have something like that, or a dash t like type. And again, if you try to do a lot of this stuff, then it's probably better to just go and learn cookie cutter and use cookie cutter. But in this case here, right, just something simple. I'm just gonna go ahead and create a requirements.txt, and then I'm gonna go ahead and create a virtual environment. Okay, so I'm just gonna assume that this is a strictly Python utility, so meant for people who primarily code in Python. All right, create a virtual environment. All right, so these are the three things that it should be doing first. All right, so the first thing is to create a readme. So create readme, and so let's say create a file name readme, .txt readme.md, and another one called requirements.txt. So requirements.txt. Right, now how do you create a file? How do you just create a file in a command line? So let me show you what I mean by that. Right, if I show you ls, currently I have demo0.py, I've started.py, but if I want to create a file, how do I do that? If I want to create a simple file, I would use touch, and touch would just, you put in a name here. So we don't need a Docker compose. That would be nonsense. I would like, this would become a 2 hours tutorial instead of a 45 minutes tutorial, right? So but if we do touch and I put in something like requirements react.txt, and if I print a list again, you should see that react.txt starts to appear here, it starts to show here, and it's now created. And I could use Vim or something, could go in there and I could change that. But I don't actually want that, so I'm gonna just go ahead and just remove that file and remove react.txt. Okay, so now it's removed, but you could use touch to create a file. So what am I gonna do here? Relatively simple, I guess. We could just go ahead and say take the project directory, project underscore directory, and we said from there create a file. So the file would just be like readme.md, and we want all of this to be wrapped into something so it doesn't just create that. Okay, so touch, and then we just want to duplicate that, and here we just want to change that to requirements.txt. right? So that is the sort of the first step. Okay, so far so good, right? So the first and the second is done. Now, what about the virtual environment? How do we create a virtual environment? So depending on what virtual environment you use, nowadays, a lot of times, you see when somebody use venv, they would just create a subdirectory called venv in there, and you would just create a sort of a gitignore and put everything in there first, and then everything that you do installing packages and stuff would just be in the virtual environment. All right. So I want to create a virtual environment, and I also want to put in a make it capitalized, create a gitignore file as well. So our tool is actually really handy, right? It handles a lot of these things for you. So I want to just go ahead and do that. So let's go ahead and make a command, create venv and gitignore. Okay. So starting from gitignore, actually let's do a gitignore first, and then create gitignore first, and then venv. Okay. So starting from gitignore, what do we do here? Now you could just create usually in a basic shell. You see, a lot of times what I do is that I would think about how I would do it in shell before I try to script it into my program. So, and this is how we develop a lot of tools, right? We always follow this kind of development process. We said, okay, how do we do it first manually? And then now, how do we put them into an automation pipeline, right? But you need to first define how you're going to perform that task manually before you can actually think about how that would make sense in the context of a programmatic pipeline, all right? So how would I do that if I want to create a gitignore? I would use the same thing. I would say touch, and I would, instead of rec, I would say .gitignore, and then I would go ahead and write it into the gitignore. So I'm gonna go ahead and say ream.gitignore, and then within that I could go ahead and just put in my like I would usually what I have in my gitignore is I have my VNV because I know that's gonna come later, and then I'm gonna have my dunder, so PyCache, because that's gonna create a lot of that file later, and then I'm also gonna have my VS Code and all that stuff, VS Code, right? And if you have more of them, then good for you, just go ahead and add more of them. I'm gonna quit out Vim now because don't really need any of them, so I'm gonna quit that out, and I'm gonna also remove that now that we know how we do that. So we're gonna say remove gitignore and make sure that's clear, right? Clear the screen. So we are gonna use the same thing here. We're gonna just create a file called gitignore, and then we're gonna add those items in there. So you could just do a touch and then append those file, put those contents into the file. You could also use a handler and just context manager, just say with open, and then open what? You could open, you could just copy this and then just type it in here. So for example, whoops, copy this with open this, and you would have a gitignore. Then of course you want to put a mode. You want to say whether you're trying to read or trying to write. In this case here, we're trying to write to that file, right? So we're trying to write to that file. So in that case, we want to say mode equals to W. W basically says write mode, right? If you want to write in binary, you put WB. If you want to read mode, you put R. And if you want to read in binary, RB, right? So mode is basically write. A lot of you probably already know that. So we're gonna just go ahead and say create a file, gitignore, put them into the write mode, and then what do? You write into that file. And so to write into the file, you could go ahead and write the, just like how we did it earlier. We have the VNV, PyCache, VS Code, all of that stuff. Anything that you need to automate, anything that you use at all. I don't know if you use Visual Studio Code, maybe you have some other kind of setup, you have some other kind of a development environment, and you want to set those things accordingly, all right? But in our case, you could go ahead and just put those multi-lines and then put a, so you could do it like that. You could say something like, VNV, and then you could escape that by putting a /n, and then you could put a second one. But there would be a lot of them, right? There would be a lot of them. You would end up putting a lot of them. For example, VS Code, and then every time you have something new again, you put that. And then if you have like Babel or whatever, you put Babel, Webpack, all of that stuff. So maybe a cleaner way to do it is to do something like this. Take a /n, and then what you do is you say join, and then you join through a list. And then within this, you could put in all of those things that we just specify. So VNV is one of them. That's the virtual environment. You want to basically put them in gitignore. You don't want to have them in your version control system because somebody could just look at requirements and install what they need anyway. You don't need to take up more space on GitHub when it's not necessary. And then you could have PyCache, and then you could have .vs code. And if you have more of them, then go ahead and put more of them. But in this case here, it's gonna go ahead and join the string. So VNV /n, which is a new line, PyCache, new line, VS Code, new line. And if you have more of them, feel free to customize this program to your heart desire, whatever that makes sense to you. All right. Make sure that you close that context. So if you don't use a context manager like that, but for me, I use a context manager. So we've opened, by the time this is done, it would close it. So if you open that and all of this is executed, it would close that connection, right? I guess let's take a look now. Create gitignore. Actually, let's do this in the second line in the next one. So let's say create VNV, and make our first commit. Okay, so let's go up. What else does this tool do? It's gonna go ahead and also make our first commit. So this tool is going to automate that as well. Because usually when I start a Git project, I also want to, so let's say initialize Git. initialize git and make our first. So usually when I start a new project, I want to initialize git and then I want to make my first commit right away, almost right away immediately, because if anything I could roll back to that. Okay, so initialize git, make our first commit, and I think it's good enough. Let's go ahead and do that. So this is where I would be using something like subprocess, and I would do something like run, and then what? So if I want to create a, let's say I want to do this, let's say I want to say create a git init, right? So I could go ahead and just do run, and I could say something like git, and you would think that I could just do something like git init, right? So if I were to just go back to Python 3 and have I imported subprocess, let's do import subprocess just for good measure, and I say subprocess dot run, and I put in git, and I put in init. Let's see what happened. It's gonna say initialize empty git repository, and this is not exactly what I want, because if you go back here, let me just list all. I'm gonna remove the git now because that's not really what I want, but I'm gonna explain why this is not what I want. In fact, if I just bring up my browser and to show you what I mean, probably makes more sense to you. So if you look at a git documentation, so this is on git-rcm docs/git. What we want though is we don't want to initialize that in our current working directory. What we want to do is to add the -c option, and then we want to pass in a path. This will run as if git was started in path instead of the current working directory. Exactly what we want, right? So we don't want to initialize the git in the current working directory. We want to actually do it in a certain specified path. So when multiple C options are given each subsequent stuff, all of this is not important. We're not gonna do multiple C options. We only just gonna have one. So but we see that here the -c and then followed by the path is exactly what we want. So I'm gonna close that out now, and I'm gonna change this to add the -c command. So you want this to be a capital C, okay, not the lowercase c. And then here, this is where you put in the project directory. So this is like whatever directory you actually meant to do. And in here we have our name as, what do we have our name as? Let's see, project name. So we're just gonna copy project name, and we are gonna just replace this whatever with the project name. So it's just gonna go into the project name, and it's gonna initialize that in there. All right. So this is how we would actually call our sub process. But we're also gonna actually continue to do that process. We're gonna go ahead and say after you do a git init, you wanna do an add. And what do we do usually? We say git add, and then what? We usually put a dot because we want to add everything, because the gitignore has already been created right here. So with gitignore being created, the dot is just gonna ignore everything that is in gitignore, and everything else is gonna be into the version control, right? So I'm gonna put a dot here, and I'm noticing a pattern here is that I'm actually starting to repeat myself a lot here. So there is something I could optimize, but let's go ahead and continue doing that. So I'm gonna just say commit here, and I'm gonna say commit, and then what else am I gonna have here? I'm gonna have a -m flag, because that's a message flag. So after the get add, you would do something like git commit, and then you put a -m. -m stands for message. So in this case here, my last message was miscellaneous changes and minor aesthetic enhancements. All right. So in this case here, I'm gonna put a -m, and I'm gonna give it a commit. In this case here, it's just the first ever commit, so there's really nothing fancy. So I'm gonna say initial commit. All right. And I could keep on doing this over and over again, but like I said, I'm actually repeating myself a lot. So what I can do instead is I can create a list of all the commands. So I'm cmds, and whoops, don't meant to put that in there. And what I can do as well is I could just go ahead and remove all of this, and then I could just remove the last one, and then move all of this up like this. So of course you also want to put in a comma, because now this is a list. It should be treated like a list. So you have the I guess we also put a list at the end of this, right? So put a comma here as well. So we have the git init. We haven't created a venv, so let's also do that. Go ahead and create another one, put a comma just so we don't forget, and then in here actually let's just do it in one line. Let's say Python, and want to say -m, and want to say take that and call venv, which is our virtual environment sort of manager, right? And then we give it a name, and the name would be something like the current project folder. So what is the name? Did I have the project? Oh, it's actually project dir, not the project name, right? Yep. So let's change. Well, good that we found that. Good that we catch that. So we're gonna use a f string and project dir, and then we say venv. Wanna also make sure that we change all of this. put it into project dir, because that is the directory, not the project name itself. So it goes into that full path directory. That's correct. Okay. So now that we have the project dir VNV, we have all the gits in here. What else do we want? Let's go ahead and maybe add a 6 item. This is optional. If you use Task Warrior, you could do that. But for us, since we use Task Warrior, and you know, like I said, if you don't know what Task Warrior is, go and check that out in my other video. If you want to build tools on top of if you want to build your own productivity to-do manager in your command line, then you want to check out my other video where I go through all of that. Okay, so in this case here, I'm gonna just add a task onto Task Warrior, because that's kind of always what I do as well. This is a very common routine for me myself, very specifically. So I'm just gonna have that. So commands, okay, and now we just go ahead and just add a command and just say create a task on our task manager. And I showed you earlier, before we started coding this program application out, to create the task, all I needed to do was to add a task, and I'm gonna say an add. And then what else am I gonna have? I'm gonna have maybe have an F string here. I'm gonna say something like write documentation, because that's usually the first thing I want to do. I want to be concise about what I do. I want to be clear about what I want to do. So I usually write documentation at the very beginning, at least create the template of that, and like, what am I trying to achieve with this project? What is the objective in here? And what am I trying to build, right? And I just want to put that out there first. And so I'm gonna just put project name. Okay, so whatever the project name is, if this is home enhancements or home automation, then it's just gonna be write documentation. I'm using an F string for that. All right. So now that we have all of this, this is command. So we can say for command in commands, and you could just run. Okay, you could just run. But if you want to be more defensive, then you could just add a try except. You could say try, and you could be more except be a little bit. Let's just write a pass here, because otherwise it's just gonna complain. Okay, and then we're just gonna have an except, and then here you can log an error or something. You can whatever, do a log, do a print, what have you, right? So this is a more defensive pattern. It's saying that, hey, if something doesn't work, I want to catch that, and then I want to print that out, because it means that I shouldn't go ahead because something is not working, and I want to know what is not working. So here, this is the subprocess that we learned about. So I'm gonna say run, and then here we're just running command. Remember how in the earlier part of this video, I show you how you can pass in check equals to true. Well, this is where we could be. We could use it. It's very handy, and we could also pass in a timeout. If anything is taking too slow, for example, more than 60 seconds, then we wanna be filling that as well. Okay, and so if something is taking more than 60 seconds, it's gonna fill with a certain exception. So let's just accept that first. We're gonna accept that with subprocess dot there is something called a timeout expired. So let's go ahead and do that, and then we say as exception, and we just say that print command timed out, nothing fancy. All right. Then what did we see earlier? Let me open up my terminal again. Okay, so if I put check equals to true and I run that again, it says there is a quad process error. So let's also handle that use case, shall we? So let's just go ahead here, and let's also go ahead and do a subprocess, and we're gonna say this is a quad process error. So this is exactly these kind of situations where we did not get a non-zero exit status, and we're gonna print something out as well. We're gonna say that command fill with a non-zero, because here in this case here it's basically exit status 2, so with a non-zero exit status. And I'm sure that at some point you could go and refine this and make this a little bit better, and like explain, you know, what you could do, and maybe give a try. You could even try and do something like import warnings, and then say that, hey, maybe you want to check this. You could do something like those. A lot of those things that I just mentioned, like warnings and stuff like that, building good CLI tools, they are in my other playlist. In the full playlist, there is like a 6 videos playlist where we build command line tools, and I talk about how to add colors to your command line, how to add nice warnings, do all of those fancy stuff that you see in command lines. If you want to learn more about that, go and look at that video. So I'm not gonna actually go into that. I'm just gonna do something really, really basic here. So command field with non-exit zero status, very, very basic. All right. What about something like trying to run something that doesn't exist? For example, this one, gedit 333 doesn't really exist, right? Here, what would it fill with? It fill with a file not found error. So it doesn't exist, it would just give you a file not found. All right, file not found is not something from subprocess. It's very simple. This is also gonna be an accept. So we're gonna just say accept. And then what are we gonna accept? We're gonna say file not found. Okay, file not found error. And we're gonna say that is also the exception. And we're gonna just say print the program that you're trying to run cannot be found. Okay, again, very simplistic. Actually, you know, if you're gonna just take them as exception, you might as well just print them out as well. So I'm gonna just say /n, and I'm gonna just put exe. So I'm just gonna print that out later. So meaning it's gonna first give our message, and then after the message, it's gonna just go into a new line, and it's gonna just maybe print out the exception as well. So might as well, right? Be helpful. So gonna close that out here, and I'm gonna also do the same thing up here, just like this. Might as well, because otherwise there is no reason why you will need to capture that as a exe. So here, do the same thing, exe exception, and I think we're about done. For command, we're gonna try to run all of this. It's gonna go through a for loop. It says for command in command. So in this case here, there's 1, 2, 3, 4, 5. This command, this is gonna run 5 times. Each time it's gonna try and run this successfully. And I guess you can add another argument to say that whether you should add as a task. If not, then put as a false. If you want to add as a task, you can add as a true. So you could have something like parser, and maybe have actually just maybe quickly just copy off that. We are just gonna call it like whether add task. If you want this to be a task, right, then you could do that. And then it's not gonna be a type equals to string anymore. It's actually gonna be action, and it's gonna be store true. Okay, so the default is gonna be false. We could, if you want to, we could just print out the whole aux. So print aux. Okay, now we don't want to call this yet because we just want to confirm that it's all exactly as we expected. So let's go back in here. Gonna remove all of this, and what we're gonna do is we're gonna just call Python real quick. So let's do it Python, and we're gonna say starter.py, and you see the add task equals to false. So that's what we expect. And if you were to rerun it, this time you can pass it a p demo project, and then you pass in a false, pass in a true. So what do we get? We get add task equals to true. And if that's the case, you can write a simple if else here to say if you know, if there is the if add task equals to true, you could run it with this being sort of appended onto the commands, right? So you could append that task add. If not, you could write you could put it as a false. So you could do a simple if else here. If the add task is true, then make sure that you also add that to a task manager. If not, run it without the task manager. So I guess there are ways you can customize that. I'm not gonna, I think for the purpose of this video, it's kind of what we need to do already. So let's just comment out all of this, and I'm also gonna just Command Shift K just to remove that, save all of this, and clear all the screen. And I'm gonna go ahead and just run Python start without the add task. I'm just gonna call it let's see, ls. Okay, so we don't have anything in here. Now I'm just gonna go ahead and say p, and I'm gonna call it car automation. So right, let's say I want to also build a Python project that's sort of customized with what I can do in my car. I can just add a project like that, and fingers crossed everything's gonna work. Let's run enter, and it's gonna say okay, trying to do that. Okay, so you see that if we were to run that project, right, it goes ahead and does the work for me already. It creates a readme, it creates a requirements.txt. If I click on the requirements.txt, there is nothing in there. That's correct. If I click onto gitignore, it sees all the 3 different lines, so that's great. And then so we have readme, we have requirements.txt, we have the, okay, we don't have a virtual environment, but we do have a gitignore. We initialize git and make our first commit. How do we know that? Because if we see the outputs in here, it creates a mode, it says created all of this and then done our initial commit. All right, so we do have that being done as well. And the other task, let's check whether we have that in the task. Let's go ahead and say task, and sure enough, we have the right documentation for task, car automation. So now is when I need to delete that because we are not really using that is not really a real task. So let me clear my screen. So everything works except the create virtual environment. And the reason for that is because when I do a python -m, I say python -m, and I do a venv, and I do a project here. So I'm gonna just say the sample project. In this case here, car automation, and I say venv. It's also gonna throw an error, but it says here the virtual environment was not created successfully because ensure pipe is not available on Debian or Ubuntu system. You need to install the Python 3-venv package. So you may need to use sudo with that command, and so it's failing command. It's not actually successful, and because of that, in here it's also not successful because it says the program that you're trying to launch is cannot be found, right? And that is why we see that this is not working. So here, and I sort of expected that because I don't actually have the Python 3-3venv. It's most times I use the work on instead. So I use a virtual environment wrapper. So the one I'm using is actually this one, and the workflow is different, but I know that it's not as common. Most people use venv, and so I show you the venv method instead. But anyway, for now, it does perform what we need with the exception of the virtual environment. I need to customize it to work with my virtual environment wrapper. But for you, if you're not familiar with virtual environment wrapper and you're using virtual and you're doing the venv, then it should work. If not, just go ahead and basically install this. Just do an apt install python 3.10 and then venv, and that would get you started, and everything should still work. But the rest of the files are created and everything's successful, so that's great. Let me try a git log. List change directory to car automation. Do a git log. Okay, you see that there is an initial commit, and it confirms with this. It has a gitignore, and if you look at the git initial commit, you can see what timestamp is that, what email is that. You can see like who is the author of that. So all of that is good. We have successfully done that, and you can, again, like I said, you can just click on the different files to sort of inspect that everything is working. But if it looks good, you could just go ahead and do a git push, and you could push it to a URL or whatever. So you could create a GitHub repo, and even that you could automate actually, right? Even that you could automate. But I'm gonna leave you here. I think this is kind of enough content for today. I'm just gonna I want to talk about this because subprocess is a very, very powerful module if you know how to use it. If you never seen subprocess and you're not sure what it does and stuff, I hope that this is a very practical, high level project example that sort of show you how you could use it and add a certain toolkit into your certain Python automation workflow and sort of elevate your day-to-day developer productivity to a new level. So that's all I have time for today. If you have any questions relating to the starter project or the code, or you can find them on GitHub or anything like that, just let me know in the comments. If you have any questions about subprocess or arg parse or argument parser, path, anything that we discuss here as well, let me know in the comments. I'll be happy to help you out. Otherwise, go and check out my other videos on my channel. I have a lot of videos that talk about building command line tools and argument parsers, using all kind of a lot of the same ideas that you see here, but building up different projects and productivity tools and stuff, CLI. All right, so I'll see you again in my next video. Thank you.